How's it going, ladies and gentlemen? Mr. Donahue here again. This time we're going to take a look at 24.1 and 2 practice problems addressing organic molecules, hydrocarbons, and alkanes. So number 1, of the following substances, which would you expect to be least soluble in water? So we know water is polar, so it will dissolve other polar things. If we take a look at HCl, that's a polar molecule, so that will be pretty soluble. Hexane is just a bunch of carbons, which makes it a pretty non-polar molecule, right? There's all these hydrogens and carbons. Overall, it's a non-polar molecule. So hexane's looking to be the winner right now, but let's take a look. NaCl is ionic. That will dissolve in water. Same with sodium nitrate, NaNO3. So yeah, it would be hexane because it is non-polar. Right, number 2, how many structural isomers does pentane have? So pentane we know is, well, let's see, pent means 5, so it's C5H12, right? So pentane looks like this. With on all of those lines there's a hydrogen, but I'm lazy, so I'm not going to draw the letter H. You just know that for each one of those lines there's a hydrogen. So this would be one possible isomer. What would be another one? Well, we can have butane with a methyl group coming off of it. So this would be 2-methyl butane. And technically, you wouldn't really need the 2 there because there's only one place that methyl group can go where it'd still be butane. And then you could also have propane. And on that middle carbon, 2 carbons coming off. We would call this dimethyl propane. Right? You may think, well, hey, couldn't I have a molecule that looks like this? And you could, but it's the same thing as 2-methyl butane. You would just number from the opposite direction. So that's not really an isomer. It's just looking at it from the other side. So how many are there? There are 3. Number 3, how many isomers are possible for butane? Well, let's start off. But means 4. So I have 1, 2, 3, 4 carbons. Right, that is basically just showing this structure. A little review of the ways to draw these structures. So we got 1, just butane, just like that. And what about another isomer? Well, we could take this carbon, and instead of putting it attached to this one, we can attach it to the middle carbon, so we would have something that looks like this. What I could totally draw that better. So I'm gonna boom, boom, boom. And this would be methyl propane. All right, you could put a 2 there, but it's not really necessary because there's only one place that methyl group would go where it would still be propane. And that's really it. So this only has 2 isomers. Or why is cyclopropane more reactive than propane? Well, if we take a look, propane has, the tetrahedral orientation, bond angles of 109.5, which is what you would expect. But in cyclopropane, we have to make a ring. That's what the cyclo part means. And that is going to stress these bond angles, right? So all these carbons, instead of having 109.5 as a bond angle, they only have 60 degrees. So those bonds are stressed. They want to break so that they can form a straight line, because picture the bonds being like springs. You have to stress those strings to make that triangle. So that's going to make it more reactive. There you go. 5, what is the name of this compound? Hey, this looks familiar. Well, let's count the carbons. We got to find the longest carbon chain. Here's 1, 2, 3, or we can go 1, 2, 3, 4, or we can go 1, 2, 3, 4. All right, so I definitely have a parent molecule that has 4 carbons. So bute, that are all single bonded together, so ane. But which chain of 4 am I going to do? It doesn't really matter. Why don't I'm going to change it up. I'm going to go 1, 2, 3, and 4. And which way are we going to number this? Well, we have a dingly dangly, a special group here. And we're going to want to number from the direction that gives us the lowest number carbon. So if I go right to left, I'd have 1, 2, be the 3rd carbon count right to left. Or if I go left to right, 1, 2, 3, 4, it would give a 2. So I want to start here and count this way. All right. So that means that methyl group, that single carbon, meth, is on the 2nd carbon. Right. So there you go. That's how you name that thing. Well, that's it for that section, huh? All right, well, I hope you found that helpful. See you in class. Okay, bye.